Hello, this video is going to be over pH and pOH calculations using concentrations of H plus or hydronium and concentrations of OH minus. So here we have a diamond that relates all the different values together. If you start with any one of these values, you can find any of the other three using this diamond. So we know the relationship between pH and pOH is that when you add them together, pH plus pOH, that gives you the number 14. Right? That's just the relationship between the two. So if you're given pOH, right, if you just subtract it from 14, that'll get you the pH value. So that is the relationship between these two values. To go from OH concentration to pOH concentration, remember that P is essentially just a negative log. So pOH is equal to the negative log of the OH concentration. So whatever that number is, the OH minus. Okay. Now, if you're given pOH and you're trying to go the other way to find the concentration of the pH, you will do the OH concentration equals to the 10 raised to the, now I'm going to write a caret, meaning that upward arrow of negative pH, or pOH, apologies. Okay. So this is just saying 10 raised to that exponent. Okay. Now, why this is the case, it's just the anti-log. It's the opposite of doing a log on the function. You'll learn more about this in Algebra 2 towards the end of the year. But just for now, that's the equation. If you're given pOH, you plug it into this formula to get the concentration of OH. Just plug and chug. Remember, these two buttons, the log and the anti-log button, are one and the same. It's the button right next to the 1 on the calculator. The log is the control that in that button, but the anti-log is just 10 to the x. Right? So you just press 10 to the x. It'll tell you to fill in the exponent for 10, the exponent for the 10, and you just put negative pOH, and that'll get you your OH concentration. If you're given the pH and you're trying to find the pOH, actually, let's go the other way first. If you're given the concentration of H plus, right, and you're trying to get to pH, same thing. The P acting on H is just a negative log, so the pH is equal to the negative log of the H plus concentration. On the other hand, if you're going the other way, if you're given the pH and you're trying to calculate that number of OHs, it's again pH, or sorry, the OH, the H plus concentration, is equal to the 10 raised to the exponent of negative pH in this case, instead of the pOH. Okay. Again, the anti-log is just 10 raised to the exponent of the pH that you're starting with, whereas the log is you're taking the negative log of the concentration to get to the pH. How is H plus and OH minus related? Well, we talked about the dissociation constant of water, which is Kw, and we saw that when you multiply H plus and OH minus concentration, that number will always equal your Kw, or 10 raised to the negative 14. Right, so it's 10 to the power of negative 14. So if you're given H plus, you can find OH minus because now you have two numbers and one unknown, or your x, and you can just solve for x. You're just dividing 10 to the to power of negative 14 by whatever you're given to find the other. So if you're given, let's say, a 0.2 molarity OH, you divide 10 to the negative 4 by 0.2. That'll give you a concentration for H plus. So with that being said, we can work out these problems. So in this example, if I tell you that a solution is 5.5 molarity, 5.5 times 10 to the negative 4 molarity, what is the H plus concentration? Well, it's just 5.5 times 10 to the negative 4. Right, I tell you in this problem. molarity. Well, OH minus, how do you find that? Well, remember, if then multiplied is equal to 10 to the negative 14, to solve for 1, you have the concentration of H plus, which is 5.5 times 10 to the negative 4 times your concentration of OH minus, which we're trying to find, is equal to 10 to the negative 14. Right? So now we just solve for the unknown, which is your OH minus, by dividing both sides by 5.5 times 10 to the negative 2. So that leads us to 10 to the negative 14 divided by 5.5 times 10 to the negative 4. And that'll equal, let's bring up a calculator. Oops. So, 5.5 E. Again, the E just means times 10 to the whatever negative 4. And we want to divide. Okay, I guess we got to type in 10 E negative 14 divided by 5.5 E negative 4. So that gives us 1.8 times 10 to the negative 10. So our OH concentration is 1.8 times 10 to negative 10 molarity. Our pH, again, the formula to go from H plus to pH is you take the negative log of it. So you have pH equals negative log of our concentration of H plus, which is 5.5 times 10 to the negative 4. If you plug that into the calculator, negative log of 5.5 E negative 4, you get 3.25 or 3.26. So the pH is actually 3.26. Again, in your calculators, when you type in log, there will be a little box right here. Ignore that box. Find a pOH. There's two ways you can do this. You have the concentration of OH. So to go from OH to pOH, you take the negative log of the OH concentration. Or we know the pH plus pOH is equal to 14, so we can just do 14 minus your pH. So 14 minus the answer, that is 10.73 or 74. Right? That's your pOH. There's a couple ways you can do that. You can also do just directly negative log of your 1.8 times 10 to the negative 10 as well. And that will get you the same answer. Right? So negative log of 1.8 E negative 10. Right? It'll get you, well, rounding errors. We rounded. So yeah, it's a little bit off. Actually, quite a bit off. Hold on. Okay. It's off by 1. Okay, I cited my mistake. If you do this properly, 10 to the negative 14 divided by 5.5 times 10 to the 4, you actually get 1.8 times 10 to the negative 11. Okay, I put a 10e. There's an extra 0 in there. Okay, so 11. So if you do the negative log of this number, so negative log of, I guess, the answer, which is 1.81 times 10 to the negative 11, you actually get 10.74, which is the same thing as getting it this way. Okay. In terms of this is acidic or basic, be acidic because our pH is less than 7, our pOH is greater than 7. So from this table here, remember if our pOH is greater than 7, it's acidic. If its pH is less than 7, it's acidic. There's a couple other ways to think about it. We have more concentration of OH or H plus when it's neutral. Remember, H plus at neutral is 10 to the negative 7, but it has more than 10 to the negative 7, so there would be more H pluses, making it more acidic. Or for OHs, we have way less than 10 to the negative 7. This is 10 to the negative 11, so it is acidic as well. Okay. When we go down to something like this table, it's essentially the same way, but in table format. Right? If you're given H plus, you can find pH by taking the negative log of this number of 2.5 of times 10 to the 8, negative 8. So if you do negative log of negative or 2.5 times 10 to the negative 8, you would get a pH. Okay, dude. You gotta put that in parentheses because the computer is reading it weird. You would get 7.6. So this is a pH of 7.6. Okay. The pOH, it would be 14 minus that. So 14 minus the answer. pOH is 6.39 or 6.4. Let's just make it easy. 6.4. Okay. The pOH, again, a couple ways of doing it. You have this H plus. You could do 10 to the negative 14 divided by your pH, which is, or sorry, your H plus concentration, which is 2.5 times 10 to the negative 8. Or you can do the 10 raised to the negative pOH to get your OH concentration. Right. So again, we can do both to show you that they work. So 1 times 10 raised to the 14, negative 14, divided by 2.5 times 10 raised to the negative 8. So that gets you 4. Okay, my calculator is not doing what it's supposed to. I don't have the parentheses in the right places. So it goes to show the importance of parentheses. You get 4.7 times 10 to the negative 7. Or sorry, 4 times 10 to the negative 7. 4 times 10 to the negative 7. So I'm just going to drag. Okay. Just going to cancel all of that. Get out of here. Okay, so we had 10 to the negative 14 divided by our 2.5. And this is all from this equation up here, where the multiply together would equal that. So to solve for one, just divide 10 to the negative 14 by what's given to get the other. So 2.5 times 10 to the negative 8. That got us 4 times 10. Just want to make sure the calculator is reading it right. 10 to the negative 7. Okay. If we do the other way, if we want to do 10 raised to the negative pH, or pOH, which is 6.4, you would get the same number, just a little bit off because remember we rounded this number. It was 6.397, stuff like that. So it's 4 negative 10 to the negative 7. Okay, again, these are concentrations, so make sure you put molarity. Do the same thing for this, right? If you have pH, you can find pOH. Do the anti-log or 10 to the negative pH for the H plus, anti-log or 10 to the negative pOH for the OH concentration. Right? This one would be basic. By the way, the first one, because the pH is greater than 7, pOH is less than 7. Okay. For the rest of the practice, they're the same. For these, I worked through the first one, right? What's the pH if you have a 0.0235 molarity of HCl solution? Remember, HCl is a strong acid, meaning whatever you start with, whatever concentration you start with, it completely separates into H plus and OH minus, meaning you would have 0.0235 molarity of H plus, as well as 0.0235 molarity of Cl minus. Now, we don't really care about the Cl minus, so we kind of just ignore that. We only care about the concentration of H plus. So if we know the molarity of H plus, we can plug in our formula, which is just negative log of H plus. So just take the negative log of that number, and that gives us negative log of 0.0235. It gives us a pH of 1.628. Okay. So that's the pH. If I want to feed pOH, you could just subtract it from 14. So 14 minus your answer. So this is your pH. The pOH is just 14 minus 1.628, which gives you 12.37. That's your pOH. And again, for the concentrations, you just got to do the anti-log, or 10 raised to the pH. So this will be 10 raised to the negative 1.628, and this will be 10 raised to the negative 12.37. This will get you your OH concentration, and that'll get you your H plus concentration. Okay. Same thing for this problem, right? You can find your OH concentration, which you can get your pOH, right? Because taking a negative log of your OH concentration gives you pOH. Now you can be able to use this table to get your other three values. Okay. Number 14 is a little bit interesting. This will be a little bit of a challenge. Remember, this has to deal with neutralization reactions. So if you have a strong acid and a strong base, if you have equal amounts of each, if you think back, they should be canceled, right? It should form water and salts, meaning there would be no or equal amounts and they would all cancel each other out. But what if you're not given equal amounts? Right? What you do have will cancel, but there's going to be some left over. That leftover will be what's accounted for in our equation. So you have to think about what is going to actually affect our pH. Would it be our HCl or would it be our NaOH? Which one do we have more of, and how much more do you have? Okay, I won't tell you the answer. I won't spoil it. Try yourself, and then see if you got it right. Okay, this is pretty much calculations for pH and pOH. You should be able to tell me the relationship between all of them and whether it's acidic, basic, or neutral. If you have any other questions, please ask.